This video goes through reciprocal functions and how to graph them. Now recall that the reciprocal of a non-zero number, a, is 1 over a. If y equals f of x, a polynomial function, then its reciprocal function is going to be y equals 1 over f of x. Now remember, we can't divide by 0. So the reciprocal of a function is going to be undefined at f of x equals 0. So that means at my x intercepts. On a graph, that is shown by vertical asymptotes. So you're going to have vertical asymptotes at the x-intercepts. So as 1 over f of x doesn't equal 0, y equals 0 is the horizontal asymptote of the reciprocal function. So we're going to have vertical asymptotes at the x-intercepts, and we're going to have a horizontal asymptote at y equals 0. Let's begin with something we've already looked at in methods, which is reciprocal functions of linear equations, known as hyperbolas, and rectangular hyperbolas at that. So use the graph of y equals x plus 2 to sketch y equals 1 over x plus 2. So y equals x plus 2, we have an x-intercept at y equals 0. So that's going to be 0 equals x plus 2, x equals negative 2. So negative 2, 0. Our y-intercept is going to be at x equals 0, so y equals 2, so that's 0, 2. So we have negative 2, 0 and 0, 2, and we need to join those dots. So that's the line y equals x plus 2. Now to draw the reciprocal function, we need to look at certain parts. Number one, easy one, our asymptote is going to happen at that x-intercept, because we can't have x plus 2 equaling 0. So in this second one, we've got y equal 1 over x plus 2. X plus 2 can't equal 0. So x can't equal negative 2. So that is our first thing, which is our vertical asymptote at x equals negative 2. We also have our horizontal asymptote at y equals 0. So we have our vertical asymptote at x equals negative 2 and a horizontal asymptote at y equals 0. Now, from the x equals 2 to the right, we are above the x-axis. So that's going to happen for our reciprocal function. If our y value is positive and we divide by that, we're going to get positive. Okay? In contrast, to the left of our x-intercept is below the x-axis, which means our y is less than 0. So when we divide by that negative, we still get a negative. So we need to be below the x-axis here. We need to be above the x-axis on that side of our asymptote. Another thing to look at is if we look at our y values on to the right of our x-intercept, we are going from low to high. If we look at our y values to the left of our x equals 2, they're going from low to high. So when we do our reciprocal function, we need to do the opposite. We need to go from high to low. And on this side, we're going to go from high to low. Think about it. If our y value is 5, 1 over 5 is small. If our y value is 1 over 5, then 1 over 1 over 5 is 5. So that's big. So it's the opposite. So when we go to our graph, the other thing we need is our y-intercept. Our y-intercept of y equals f of x is 0, 2. So for y equals 1 over f of x, it's going to be 0, 1/2. So I'll put that in as well. So we need to go from a high value to a low value, and we can't touch our x-axis. And then on the other side, we need to go from high to low. So that's y equals 1 over x plus 2. Now you were sketching those in methods, just realizing that y equals 1 over x plus 2 had a horizontal translation 2 units to the left, so your asymptote moved. So now you're just looking at it in regards to that original function, which are really important when they get harder. So if we look at this next one, we have y equals x plus 2, x minus 4, and we want to sketch the reciprocal. So we're looking at the reciprocal of quadratic and cubic functions. So that's a quadratic. So a parabola. And we'd have a positive x squared, so it's a happy parabola. Our x-intercept, so when y equals 0, so x plus 2, x minus 4 equals 0, x equals negative 2, x equals 4. So as actual intercepts or coordinates, our y-intercept is when x is 0, so it's going to be y equals 2 times a negative 4, which is a negative 8. So 0, negative 8. Our turning point is halfway between our x-intercepts. So that's x equals 1. So y would be 3 times negative 3, which is a negative 9. Oh, not 0, negative 9. 1, negative 9. So join the dots. It's not going to look very good. There you go. So that's y equals x plus 2, x minus 4. Now to use that to draw the reciprocal function, think about what's above the axis, what's below the axis, and also your asymptotes. Okay, so we're going to have asymptotes at x equals negative 2 and x equals 4, and also our horizontal one at y equals 0. So let's label this. So our asymptotes are happening at our x-intercepts because we can't divide by 0. So let's draw those in. And we also have our horizontal one. Now, above the axis for x is less than negative 3, below the axis in between negative 2 and 4, and above the axis for x is greater than 4, we have a y-intercept for y equals f of x at 0, negative 8. So for y equals 1 over f of x, it's going to be at 0, negative 1 over 8. So about there. Our turning point of y equals f of x was a min at 1, negative 9. So for y equals 1 over f of x, it's going to be a max at 1, negative 1 over 9. So this is hard because these are very small values. So that's 1, negative 1 over 9. From this side, we're going from low to high. So we need to go from high to low, and we're above. From this side, it's low to high. So we need to do high to low. And then we have our maximum turning point. There. So this is y equals 1 over x plus 2, x minus 4. This one's more for an example. If y of x doesn't have any x intercepts. So you can see this parabola here, y equals x squared plus 2. That's y equals x squared moved up 2, which is why it doesn't have any x intercepts. So that means we're not going to have any vertical asymptotes of our reciprocal function. We'll still have that horizontal asymptote. Okay, so we have for y equals x squared plus 2 a min turning point at 0, 2. So for y equals 1 over x squared plus 2, we're going to have a maximum turning point at 0, 1/2. And you can see that on that next graph. Okay, y equals x squared plus 2 is above x-axis. So y equals 1 over x squared plus 2 is above the x-axis. Our y-intercept for y equals x squared plus 2 is at 0, 2. So it's going to be for 1 over x squared plus 2, 0, 1/2, which is the same as our maximum turning point anyway. Now, if we look at the quadratic, we go from high to low to high. So when you look at the one down here, it's going from low to high to low. Let's look at the reciprocal of a cubic. So we've got y equals x minus 2, x plus 1, x minus 2, and we're given the sketch. So first of all, you can see these x intercepts, which are my asymptotes. So I'm going to put those in straight away. So I've got x equals 2, x equals 1, x equals negative 1. So asymptotes at x-intercepts. So that's going to be x equals negative 1, x equals 1, x equals 2. We also have our horizontal asymptote at y equals 0. Okay. For y equals f of x, our y-intercept is at 0, 2. So for y equals 1 over f of x, our y-intercept is going to be at 0, 1/2. So let's make that there. We have a maximum and a minimum. So we need the reverse of that in our reciprocal graph. So we might be down, needs to just line up. We don't have an actual value, so we'll put it about there. We are above the x-axis in the yellow, and we are below the x-axis in the blue. So we need to be below, above, below, above. So our maximum turning point became a minimum, which is about there. We need to go through, so something like that. Now this minimum turning point, we need to think about what x value that has. We've got the -3 here. So if we divided our y-axis, it's less than -1. So if you divide it by a fraction, you end up with a bigger number. So this max, okay, that's a minimum turning point. So this minimum turning point has to become a maximum, but it needs to be at a lower point because this is a fraction. So let's put it about there. Okay. Then we have this yellow section for x is greater than 2 from high to low. Sorry, we have from low to high. So we need to go from high to low. And then for our x is less than -1, it's going from low to high. So we need to go from high to low. So this is y equals 1 over x minus 1, x plus 1, x minus 2. So you can see we have a min now there, and our max is now there. So it's the reverse. Just to provide a summary, things that we've looked at. If our x-intercepts at x equals a, then our reciprocal function, that's going to be a vertical asymptote. If we have a maximum for y equals f of x, that becomes a minimum for our reciprocal. And vice versa, if we have a minimum for our function, it's going to become a maximum for our reciprocal. If for our original function we're above the x-axis, then we remain above the x-axis for our reciprocal function. Similarly, if we're below the x-axis for our basic function, then we're going to be below the x-axis for our reciprocal. If we're increasing over an interval for our original function, then we're going to do the opposite. We're going to decrease over an interval, and vice versa. Values approach infinity for our original, then values are going to approach 0 from above in our reciprocal, and vice versa. Now these ones here are just when I'm talking about that going from low to high, becoming from high to low. If we're going from high to low, it's going to go from low to high.